Alrighty, welcome to Simplifying Radicals, Part 1. And what we're doing here is, well, let me explain first of all. We're going to take what we call an entire radical. Okay, so what do we mean by an entire radical? Well, it basically means something like root 40, okay, where there's kind of no visible number out in front of the radical. Everything is basically under, whether it's a square root or a cube root or a fourth root, but there's no extra numbers floating around outside. And what we're going to try and do is we're going to take these things and break them down from an entire radical to what we call a mixed radical. Now, a mixed radical has a number out in front. So let me just show you how I'm going to take this one and break it into a mixed radical and show you the process. What we're going to do is we're first of all going to rewrite that root 40. So you can take that 40 and write it as 4 times 10. Now, why 4 times 10 and not 2 times 20 or 1 times 40 is, I'm going to show you that in a moment, but just bear with me. When you take a number and you break it into factors like this, you're also allowed to split up the radical. So I can write this as root 4 times root 10. So I'm breaking splitting the radical now into two separate radicals. And here comes the mixed radical. I look at root 4 and I go, the square root of 4 is just a 2. And then I still have times root 10. So I'm going to write it like this. Okay. Now you'll notice this 2 is not like a little tiny 2. Okay. It's a big number out in front. And really what it means is 2 times the square root of 10. So be careful with this that you don't mislead, and you don't want it to look like a square root of 10 or something. Well, it is the square root of 10, but there's a 2 out in front as well. Okay, this is a mixed radical because it has a number out in front and a radical. So let's carry on with the next example. Okay, we're going to up the ante a little bit, make it a little bit more bigger number. Okay, so how do we break this thing apart? Well, we're going to look for two factors here, some numbers that multiply together that make 98. But we can't just pick any old numbers. The whole key to success here is that we picked 4 because when we square rooted the 4, it becomes a nice whole number. Okay, that's the key to this thing. If I used 2 and 20, it wouldn't get me anywhere because the square root of 2 doesn't fall into the category of becoming a whole number, and neither does the square root of 20. So you got to pick your numbers wisely. So you got to look at this, and I got to think about, well, what are nice square numbers that might be factors of 98? In fact, what are square numbers? Well, square numbers would be 4, and that's because the square root of 4 becomes a 2. Okay, so that's a square number, and 9 is the next square number. Then there's 16. Okay, and you probably remember most of these. Okay, and 25, and then it keeps going on forever, right? So what number is a factor of 98 that is a square number? Well, I never got to it, but I was thinking of 49, okay, which I happen to know is 7 times 7. So that might be very useful. And that times 2. So when I split my radical now, I got root 49 times root 2, and there's my answer. It is 7 times root 2. And there it is as a mixed radical. All right, now let's mosey on. Okay, so clear the page. What if we got a cube root and we threw that at you? So cube root of 16. Okay, so we're dealing with cube roots now, right? So we're still looking for two factors, but we're not thinking of square numbers anymore. Now we got to look for some useful cube numbers. So like what would be the first really useful cube number? Cube root of 8 is useful because it is a whole number. It's a 2. Another good cube root beyond that would be the cube root of 27, which is 3. And these tend to grow pretty quick. it doesn't take long. You start getting into some pretty big numbers here. I'll just show you one more. Usually we don't go much beyond this. This is kind of the end of the road for cube roots, just because they get to be so big. Well, I can see one of these numbers here, like this 8, that's a factor of 16. Why don't we split it up here and do this? So now I have cube root of 8 times that by the cube root of 2. So there it is. I'm ready to write my answer. This becomes a 2, and that's times the cube root of 2. So I've now reworked it and wrote it as a mixed radical. All right, now we're going to get into the tougher ones. In fact, I'm going to clear this whole page because I need room. We're getting up there with the big bad ones now. Okay. Let's break down this cube root of 16x to the 4. Now, we got to try to break this thing and simplify it down as much as possible. So here's what we're going to do. We're going to take this whole cube root thing, give ourselves lots of room, and what we're trying to do is it possible to make 3 items that are identical, and whatever's left over we just leave at the end here, and maybe then I can split it all up. So this is kind of what I'm looking at here. Is I'm looking at what's the biggest group of 3 identical items that would be factors. I'm looking at this and I'm thinking, okay, I see that 16, so I'm going with 2 times 2 times 2, which would be an 8 actually. So there would be another 2 left on the outside. Okay, kind of the odd man out. Then I got 4 x's to work with here. Well, why don't we put an x in each of these? Okay, so there's 3 x's accounted for, so there's an extra x on the outside. Now, the reason I put brackets around these 3 is because now I'm going to put them together and think of it all this way. I'm thinking of it as I got these 3, and then I got to times that by the leftover stuff that didn't quite make it. Now, what's good about this is, well, you're cube rooting something that is being cubed. So that just turns into the something. Anytime you have cubing and cube rooting, they kind of undo each other. So whatever we had in the brackets here is all that's left, and I've got to times that by the cube root of 2x. So these are the leftovers over here. And these are the guys that got out, as it were. Okay, it's a little bit tricky, those. Let's do one more like that. I might even, I better give myself room. Okay, so here we go. So this will be a nice square root. Let's work with square root again. And let's get some bigger numbers going here. How about 200 and x to the 5th and y to the 4th. Okay. So what are we trying to do here? Well, we're trying to get things out from under the radical sign. And to get them out, we got to put them into 2 groups. Now, why 2 groups? That's because this is square root. Okay, square roots means I like to find 2 groups that are identically the same. And then all the extras I'm going to throw out here. So let's look at 200 first. How about 10 times 10, which would be 100, and then times 2. So there's my 200, and I was able to make 2 identical numbers in these 2 little sets of brackets. I'm going to do the same thing with the x to the 5th. The most x's I think I could put into each set of brackets would be 2 of them. Okay? And then there would be 1 extra x left over. Okay, now what about y to the 4? Well, why don't we just put a couple of y's in here and a couple of y's in here. Okay, so we got a couple of wise guys here. Yeah, and then there's nothing left over. So now I'm ready to look at it this way. On the one hand, I've got 10x squared and y squared all being square rooted. Whoops, being squared. So fit that in. And then multiplying that by the square root of the leftovers, 2x. Well, this stuff here, you're square rooting, but you're also squaring, so that just turns into whatever's in the brackets. So you got these guys here sitting out in front, and then you're going to multiply that by the square root of 2x. And so now we're all done. And just maybe that's where we're going to stop for today. And we'll come back with more exciting radicals.